All right. So we only missed that one little bit. That's not too bad. Now I'll start recording. Drive axles. It again, it's going to be very similar to what you're doing with a steer axle, just a few less alignment components or different alignment components. What we have for alignment on here, instead of having shims to adjust caster, because caster is only something you will get on a steer axle, okay? Because we don't have that, we have this torque rod and it has adjustments here. So these 10 axle alignment washers, what they'll do is they'll adjust the positioning of this torque arm, torque rod to the hanger. They'll either push it out or in. And that's going to adjust your axle positioning. That's how you can attain it in this one. Another way that's very common and probably in trailers is this torque arm will be threaded. So you'll have this side is on there and this side is on there. This whole rod in between here is threaded. Half of it will be threaded in one direction and half of it will be threaded in the other direction. And the reason that is, and I mean one direction and the other direction, is one side of the rod will be left-hand thread and the other will be right. And the reason that is so that as you want to adjust it, you can take a pipe wrench on this rod itself and start rotating it in one direction, and turning it one way will draw both ends in, and turning it the other way will push both ends out. So that's how you can get alignment on that. So this is what they talk about, scrub angle and thrust angle. So ideally what we want is the thrust angle, the direction that the drive axles are pushing down the road. We want it to be the same as the direction the vehicle is going down the road. So our frame parallel, these are not quite parallel. Does anybody know what or remember what the definition of parallel is?
Something about two lines staying exact same distance apart, blah, blah, blah.
And never ever touching. Yeah, that's what it is. So if this tire went straight ahead separately from the frame, it would never ever touch the frame if the frame and the tire went infinitely on forever, because it is running parallel to it. Whereas this one, the frame is running this way, but the tires are going this direction. Or the wheels, I guess I should say. The wheels are going in this direction. So you can see they actually will cross paths eventually. So they're fighting each other. What you're going to end up having then is tire scrub. That's how you're going to wear out tires. This is what we're trying to avoid when we're aligning vehicles. For us, we're going to be just aligning trailers, so it's a little bit different than aligning tractors. This is what I would do. If I was changing any kind of bushings, I would go to a press. If I can, that's where I would do it. It's so much easier, so much less fighting, so much less air hammering. Okay, that's going to be a problem. Tandem drive, it'd be exactly the same as a single, except you're going to have that equalizer in there. So what that's going to bring with it is some extra wear points and some extra bushing. So there's going to be a bushing inside of there, wear points on either end of that equalizer there. Other than that, it is the same. The way you adjust the alignment is going to be the same. Okay. Here's just a picture of us. So this particular bushing is split. Most of them aren't like that. They're going to be pressed in just like on the eye of a spring, just like a torque arm, just like any kind of bushing that you probably are used to by now in suspension. Equalizer beams. These are big bushings. So who's worked with these kinds of bushings before? Anybody out there? So when you're checking your bushing for clearance, what you want to check, what they're talking about here is you can use this jack to try and lift up. And what you're looking for is you're looking for any difference in movement between the hanger and the beam. So if this hanger starts getting lower and the beam starts lifting up higher, you're going to have wear. Every manufacturer is going to put out a spec for that wear. All right. Now, if you're working on a unit that has a sub-assembly like this, so you can see here, it looks like if the wheels were on there, it would just roll right out. Chances are it's easier to work on if you're doing that. For instance, if we were changing drive axles on like a water truck or something, it is pretty much impossible to get all of it in there without taking the tank off. But that takes so much work. And so essentially what we would do is just wheel the axles out from underneath, put everything back together, wheel it back in and reattach the suspension. And that works really well with equalizer beams. Does anybody work with wheelers?
I do.
I'm sorry. Very sorry.
16 and 24.
Oh, that's no fun. Lots and lots of wheels. So essentially what a wheeler is, and I'll draw a picture of it in a couple ILMs down the road here. It just doubles the amount of axles on every axial plane. And I'll explain what that means in a bit. A wheeler is the same like this. When it comes to working on it, I would probably take the whole sub-assembly out and wheel it out from underneath of the frame. And then you're going to be able to work on it a lot easier. Okay. Is that what you find you do when you're doing a lot of repairs on it?
If we're doing a full brake job, we do, yeah. Like
Yeah.
pushing.
Absolutely. Yeah. Because the brakes, like you have one wheel end here and the other wheel end here, and then you have a brake chamber here and a brake chamber here. So there's not much room in there with the frame in between, right?
With the outside, you can undo the hub and slide the drum and everything off. With the inside, you got to take the wheels off.
So I guess it just depends on how many wheel ends you're going to end up doing or something, right? So if you're going to be doing any of these large bushings, and I'll show you what one of them looks like one day. Typically, for those of you who've done pivot bushings, they're very, very similar. So Hendrickson, the trifunctional bushings you're talking about, sells a special tool for pushing and pulling those out. So those are rubber bound bushings inside a steel bore. These bushings and these equalizers, they have a steel sleeve. So it's steel cased rubber bushing pressed into a steel bore. You will never get that out unless you have the proper press. Well, you can get it out. You can cut them out, grind them out, pound them out, melt them out. But getting the new one in there properly, good luck. It takes a lot of force to get those out and in. And then just a different kind of bushing that has a grease fitting. These are quite old. We probably won't see many of these anymore. But be aware that if you see grease Zerk on there, you might want to look into if you should be greasing those, because otherwise the life expectancy on those will go significantly down. So this type of assembly they'll also sell if it's a rubber bound bushing. A steel bound one would be really, really difficult to put in like this. The steel ones go in very tight. For anyone who's ever driven a steel bushing into like a spring eye, or torque rods typically have rubber bushings, so those ones go in a lot easier. One thing about the presses when we're pushing in bushings, and same thing with, where is the picture of it? Same thing with those Hendrickson trifunctional bushings. So we have a bushing installation tool, the beam end, and you have your bushing inside of here. The trifunctional tool, it looks like a big tube. Okay, and that's just like the picture they showed us down here. So this is essentially the sleeve, right? For our trifunctional bushings, it's a large aluminum sleeve. You'll put a cap on here, and then there'll be a threaded rod that comes out of it, and you then use a plate that will fit inside, and this is how you can pull them in or push them off, okay? Sort of makes sense? The inside here is actually quite special. So the inside of that tube is going to look like this. It's not just an opening. It has a little lip on it like this. What this lip is going to do is while the bushing is being driven into the bore, it's going to compress the rubber on either side. And if you have the proper tool for any of these rubber bushings, all of them are going to do that. So as they're pushing it in right before they go into the bore, they're actually compressing them a little bit down to squeeze it in, and then it's allowed to expand as it gets back into the bore. Has anyone ever experienced lots of rips and tears in their bushings as they're trying to install them?
You got to use the lube.
Yes, you do have to use lubrication. So I would absolutely use lubricant to try and get these bushings in. That's a good way if you don't have the proper tools as well. What do you use for lubricant on that when you're installing them?
It
The bu-
usually comes with a box.
Yeah,
it's-
there's usually a pack in there with them.
That Hendrickson yellow, gooey, sticky stuff, right?
You betcha.
Yeah, it looks like honey, but it doesn't taste very good in your tea. And that stuff works really good. And we used to, so we do so many of these at the suspension shop. We would do so many of these, we'd have extra packages of that kicking around. And so just anytime we would do any kind of bushing work, we would use that. Essentially, we just kept a box of all those little packages by the press, and then we would just use that Hendrickson stuff. It works really well.
When I worked at Fleet Brake, I figured out a way to get the line up without getting it crooked. I would take my square, and from the notch that I used my chisel and made a notch where the original mark was on the original bushing, I would take my square and make a paint marker line across the part on the frame or the part on the arm.
Mhm.
And then I would be able to watch the line, make sure it lined up like I would make the line on the inside as well. And then I could watch it and line up the bushing when I put the plate on the other side when I was driving the new bushing in. And I found that it greatly increased the accuracy of my mark.
Oh, perfect. That's good. Well, I'll show everybody in the shop what that mark looks like as well, or what it is you're talking about in the trifunctional bushings. I mentioned it briefly yesterday, I guess that was, or the day before, about how those, no, yesterday, how those trifunctional bushings go in, and that there's a specific way for it. All right, how do we inspect these? Well, fortunately, these ones are probably one of the easier ones because there's less components, less moving parts. So all of the bushings are going to be inspected the same way. You're going to be checking for excessive play, any wear, side-to-side movement, ripping of the bushings, okay? Not only on this one are we looking for cracks, we're going to be looking for this same type of crack on any of the hangers. And it is a fairly common damage that I've seen is cracking of the hangers, okay? You want to look at those rubber load cushions and make sure they are still in good condition. And then our vertical drive bushing needs to be in good condition. So another rubber bushing that might need to be replaced as well. I think the rubber suspension ones are probably the easiest to maintain, easiest to repair. Yet again, they're saying to take the whole axle assembly out of the vehicle, makes it easier to work on. If you can, it absolutely does. Absolutely does. And I keep saying to take it out. Some of you might not realize how really easy it is. this is attached to the frame here. This will have your wheels and brakes and all that good stuff, and the axle with the differentials and all this. All it is these here. So there's caps and these studs here. You take those 1, 2, 3, 4, 5, 6, 7, 8 nuts off and those 4 caps off. You can lift the whole vehicle off of these equalizer beams and then roll it right out of the way. So it's actually very easy to get it to this point that they're showing us here, where you have the whole drive axle assembly out from under the vehicle. It's a lot easier sometimes than trying to fight with under there. Like, it depends with what you're doing, right? So the harder the rubber load cushion, the less it will deflect, so the greater its load carrying capacity. So we determine the hardness of the rubber by what's called a durometer. So the lower the number, the softer it is, or the higher the number, the harder it is. So a 40 durometer is a lot squishier than a 70 durometer. 40 durometer would be more like the rubber eraser on your pencil, and a 70 durometer is getting up to more like the plastic in, I don't know, your phone or something like that, or probably not that hard, but a lot stiffer rubber, okay? And air springs. So now we've gone from the simplest suspension to the most complicated one. So a lot more to check. These are typically the beams that we've seen, okay? Because Air Ride is so popular. This particular suspension is, it's from a Freightliner, but they make all kinds of this for tractors. And I used to see lots of tri-drives that had a suspension very similar to this, a New Holland version. So it would have this very large nut at the end here, holding this stud into this beam with this bushing here. So we used to have to change the all 1, 2, and 3 bushings on each axle. So 6 times 3, so all 18 bushings. You can't do this under the unit. You have to take this whole beam and this beam to the press. So for every axle, you have 1, 2, 3 beams to take to the press and push bushings out, push new ones in, redress these threads, and install it back again. It's a very, very, very big job. Has anybody done those kinds of bushings or work at all?
We had to do it on a tank truck at Maximum once.
Oh yeah, it can be a lot of work. Can be a lot of work. You inspect these essentially the same way. The manufacturer is going to recommend a certain amount of play and wear that you can have between hangers and bushings. If it goes beyond that, it's worn out. That's essentially how it's going to look. So the other things, what is it that adds all the complexity to this? The air system. So we have our airbags with all the air lines, the valving, controls, a lot more parts. Typically now we're gonna for sure have shock absorbers. So those might be leaking, they might be loose. Shock mounts loose are probably a huge thing. You can always check shocks and probably find one that's loosened off or was installed incorrectly, or where the mount has been worn out and then now probably should be replaced, but they just tighten it up and then more wear occurs and it loosens the shock again, and so on and so forth is most likely what you've seen. So the air springs. So just like when we're changing those spring pins on leaf springs, don't just put a jack and hold these two apart and then take the airbags out. Don't use the other airbags to hold the weight up while you're removing this airbag. Now, can you use the other airbags to lift the unit really high so that you can put it on jack stands or frame stands, absolutely do that. But don't rely on the airbags. Has anyone seen an airbag pop?
Yep.
How much warning did it give you?
0.
Yes. So if you have your hand in between the frame and here, and you have behind you is an airbag that's holding the weight of the vehicle up, will you be able to pull your arm out of there in time if that airbag explodes?
No.
Because I guarantee you're not going to hold the weight of the vehicle up either. So you're not going to catch it no matter what you think. So yeah, don't ever use the airbags. And this goes for hydraulics too. You don't use air, you don't use fluid, you use something solid and mechanical to support the weight before you go on it. Same thing with a load. You don't go under a load that's on a string. It needs to be held up with something solid, okay? A solid block, a solid piece of steel, a proper bench, a jack stand, a frame stand, something that is solid, okay? Now, do those break too? Of course they do. But if your Harbor Freight jack stand breaks, it's guaranteed to operate, so your wife can sue Harbor Freight and get a whole bunch of money for your injuries. Okay, so there's a difference there. And I mean, accidents and things do break unexpectedly. And I mean, even the most well-designed components break. So they just went through a big push at a lot of shops. When I was in there, we were doing that core program, and we had to replace, essentially we had, where is my whiteboard? We had sawhorses. So can you see my whiteboard right now?
Yep.
Okay. So what we had on these sawhorses, they were huge. They were made of like really thick steel, square channel. It was really.
I can't see if you're actually drawing right now, though.
Oh, okay. Hang on. Let me try this again. I think something. I pushed the wrong button. Now, can you see my drawing?
Yeah.
Okay. So really, really thick, but they were homemade. So they were made to excess, right? Like they were made really, really well overkill on the steel, basically. Huge, thick legs on these things. It could have held up, like we could have put a tractor on a set of these easily, and it would have held it up. I would have never been worried. But because they were homemade, right, there was no little sticker on here that said the weight, who made it, who guarantees that it will hold up this weight, right? So we had to scrap them, get rid of them. And what did we have to do? We had to go buy some. So we went and bought some. And what did they look like compared to that? They were super skinny, super thin, super tiny, with these tiny little piddly legs that were like 1-inch square tubing. But it had a sticker on here. And the sticker said the set of these can hold up 5,000 pounds. And I was scared every time we put stuff on them. So we do have to use these nowadays. This is what the big push is to get everything certified. Would these have held up 5,000 pounds? I'm sure they would have. That's what they're sold as. This place wouldn't be in business if they were selling things that hurt people. So especially a company that sells things in the States, you can, if you say that that holds up 5,000 pounds and you put $49.95 on it and it falls and crushes somebody, there's going to be a lawsuit. Absolutely. So it's so I just find it a little bit funny that that kind of stuff is happening. Okay, does homemade equipment work okay? And does, like, will we make things better than they need to be? Most likely, but it's all about that liability thing. Unfortunately, that's the day and age we live in now, where that's what we base a lot of things on. Make sense? So always hold things up with something solid, okay? Jack stand, frame stand, something like that.
What would the safety margin be on that 5,000-pound skinny little jack stand that you had?
You know, I don't even want to know. Like, I don't know what the safety margin is supposed to be on jack stands, to be honest. Like, so you're saying, you're basically asking, like, it's rated for 5,000. How much could I put on it before it breaks, right? Like, what's the safety margin there? I have no idea. Like, I'd be willing to bet the ones that the welder made could have held up way more weight before breaking than the other ones, but they only build it to rate for 5,000 pounds. What the actual rating is, would it break at 10,000 or 15? I don't know.
6,500?
Yeah, 5,001. I don't know. And yet again, that's a way they can say, well, you put 5,001 pounds on it and it broke. Not our problem. Right? That's a lot of what it is too. The ride height control system. So this is something very important, and this is probably the easiest thing to get messed up, because operators and technicians can muck around with these things really, really easily. And for any of you, or do I have any class 1 operators who just came off of the haul roads or anything like that, or truck driving years, or?
Yep.
Yeah.
Oh, perfect. So you guys have heard the stories then, where, you know, if you bend this rod or if you make this rod longer, you'll get a better ride because you'll have more air in your airbags, less air in your airbags, whatever the story is, right? You heard any of that stuff?
No, I don't touch it.
Okay, that's good. So we briefly talked about this yesterday too. You'll change all of the suspension angles, you'll change your driveline angles. It doesn't make it more or less cushier. It changes the height that your vehicle sits at. So the misconception is that if I push this so that it needs to lift it higher, there's more air in the air spring, and so it's going to ride stiffer. Or if I change this so it's lower, there's going to be less air in the air spring, so it rides cushier or softer. That isn't how air ride works. Now, that's because of the advantage of air ride. It always keeps it at the same height, and it only adjusts that air pressure based on the weight that's on there. And we haven't quite talked about hydraulics yet, but I'll talk a bit about that today, how that works as well. We'll talk about that in a minute. So how do we adjust these things? Well, there's 2 main ways. This rod is adjustable. So there's either versions you can cut to length, so you can buy a new one and adjust the length you'd want it and install the mounting arms on it. The other version you have is an adjustable rod where there's many, many little holes in the rod, and so you can put it together in many, many different lengths. The other way we adjust it is with the mount. So in this instance here, you have a solid hole and a slotted hole here. What that enables you to do is rotate the actual valve itself. So by rotating the valve, I can adjust where the on-off position is. So essentially, how we have it here, if I have the valve like this, my on-off is straight up and down. If I want to change where my ride height would be, I would rotate. So let's say I want to rotate it that way, down. So I rotate it on the mount. Now my arm off position is down here, which is going to change the ride height. And going the other way, same thing. If I rotate it up like this, it makes my off position right there, or my ride height position there. So changing where the ride height would be. And that's how we would adjust that style. Not as popular anymore. This image is from Freightliner. Does anyone still see those adjustable mount ones? No, not many people have seen that. Typically what you're gonna have is this adjustable linkage. If you've changed this linkage before, you've seen that they sell them individually. It's a very common part. It does wear out actually quite often. It's exposed to the elements a lot or exposed to the road surfaces a lot. So it definitely does wear out and get damaged and bent and broken. You can see here, where is it located? Here's a good picture of it. So this is on the air spring. This would be at the back of the drive axle, right? So essentially you'd have a drive wheel right here. Your dualies, right, would be right in here, spitting stuff all up in there. Okay, so it can get exposed to a lot of wear. So I hope everybody did the self-test already. And we will talk about it, just not yet. Okay. So we will go over the self-test today, just not yet. Any questions about these two ILMs and suspension and frames and alignment? Nothing? Everybody's doing good? All right, I'm going to just stop this recording.